but let's go ahead and get started. So I am recording the session. I got your message, and I see that you're here with us too. So what I wanted to do, y'all, is go over 2.5, and um, then we can answer any questions from homework and stuff from chapter 2 after that. So let me make sure that this is working. Here we go. Oops, here we go. Got my pen. All right, so 2.5 is equations of lines and linear models. And so, guys, we talked about this last Tuesday. We talked about that y equals mx plus b business. And so what we're going to do here, it says find the slope and y-intercept of the line with the equation. So they give us an equation right here. And what we're trying to do is we're going to try to take this equation here, and we're going to try to put it in this, excuse me, in this format. So if you notice here, this equation is solved for the letter y. So what we're going to do is we want to get this guy by itself. So if my equation is 4x plus 5y equals a negative 10, the first thing I'm going to do, I'm going to move that 4x to the other side. And since we're crossing the equal sign, that 4x is going to become a minus 4x. And we still have the minus 10. And so now what we're going to do, we're going to divide everything by 5. So we're just going to go one piece at a time. And those are going to cancel. So we're going to end up with y equals negative 4 over 5x. And then a negative 10 divided by a positive 5 should be a minus 2. Okay, so now that we did that, remember what it is we're trying to do. We're trying to find the slope. So remember, m is the slope. So in this case, my slope is the negative 4 over 5. And then our y-intercept, it's always the point 0 and then whatever b is. So in this case, it's a minus 2, right? And so that's all really I'm trying to do for these problems, okay? So we talked about this equation last week, and we're obviously still using it here today. And so let's see if we can do the next one here. So I'm going to zoom in just so I can see that a little bit better. And let's see, it says use the graph of f of the linear function shown in figure 45 to complete the following. So we want to find the slope, the y-intercept, and the x-intercept. Okay, so let's see if we can do this. Number one, we're going to look for the slope. So remember what the slope refers to. It's the rise over the run. And in this case, y'all, our line is going down. So I know that my slope is going to be negative. So really what I'm trying to do is, if I want to get from this point here to this point here, I got to move down one space. Since I'm moving down one space, I'm going to call that a negative 1. And then I'm going to move to the right, 1, 2, and 3. So here's my slope. It's negative 1/3. Okay. And then we're going to find the y-intercept. So the y-intercept is always going to be the point 0. And then remember, when we talked about the y-intercept, we said the y-intercept is always going to be the point on that line. So in this case, the point on this line is at negative 1. So there's my y-intercept. And then we're going to do the same thing for the x-intercept. So the x-intercept, just like the way the y-intercept has the first number being 0, the x-intercept has the second number being 0. And the x-intercept just means where does it hit the x-axis? Well, it hits it right here at negative 3 and 0. Okay. So we found the slope, we found the y-intercept, we found the x-intercept. Now we want to see, can we write the equation? Okay. So the only thing I'm going to do here, y'all, is when we write our equation, we're going to write it like the same way we've been doing before. We're going to go with y equals mx plus b. And so I'm going to write y equals m. We found that earlier to be a negative 1/3 x. And then my b in this case should be the number minus 1. And guys, because it's given to us as a function, what I'm going to do is that instead of writing y, we're going to write it like this. F of x is negative 1/3 x minus 1. And all this is y and f of x mean the same thing. And all we're really doing here, y'all, is just writing it using that kind of like that function notation, okay? So let's see. So far we're doing okay? Seems good? All right. So let's go ahead and go on to the next one here. And the directions here for these problems, y'all say, let's see, we're going to write the equation in slope-intercept form. So again, just a reminder, all that means I'm doing is I'm putting it in this y equals mx plus b, okay? So if you notice the first problem, it's a straight plug and chug problem. Here's my m, here's my b, so I'm just going to write y equals m, which is 5 with an x, plus b, and b in this case is 15, and so there's my line, okay? All right. Now, let's see if we can do the same thing for the next one. It says it's going to go to the point, hello, it says it's going to go to the point -2 and 5, and it has a slope of -4. Okay, so just like we were doing before, y'all, I'm going to write out this equation here. Y equals mx plus b, right? I already know the slope is -4, so I know in this case, m is -4, okay? Now, they didn't give me the value for b. They didn't give me the y-intercept. They just gave us some random point, okay? So when I think of this point, -2 and 5, remember, every point has two coordinates. It has an x coordinate, and it has a y coordinate. So what I really want to do here is I want to come back and I want to use this m, and I want to use this point here. So if you look at the first part of my equation, it says y, and I know in this case y is the number 5, so I'm going to put a 5 right here. And then the next thing it has is m we already knew was -4, and then we have an x in this case was -2, so the only letter that I don't know right now is the letter b. So I bet you we can find it. So look, we're going to go like this. We're going to say, look, let's multiply those two numbers together. So a -4 times a -2 is a +8 plus b. And then I'm going to go like this. I'm going to go -8 and -8. So here's my b. And 5 minus 8 is going to give me -3. And so now, if I know that m was equal to -4, and if we just found our value of b to be the number -3, then I bet you we can come back to this equation right here, y equals mx plus b, and we can fill it in. We can say y equals m -4x plus b. b in this case is a -3, and we're done. So really what we're doing here, guys, is we're still using that y equals mx plus b format, right? The first problem that we did there where it said that m is 15 and b, or m is 5 and b was 15, all we had to do was just take those numbers, plug them in. We didn't really have to do much else, right? Because we're just putting in the y equals mx plus b format. But when they don't give me the value of b, they just give me some random point, then what we're doing is we're taking that point here, and we're remembering that the first number is x and the second number is y, and we're plugging in those x and y's here, and we're plugging in that value of m there, so that we can find our value of b. And then once we do, and we knew what m was, all we're doing is we're coming back to this form, and we're just plugging those numbers in like this, right? All right. So let me zoom in a little bit here so you can see that a little bit better. And again, we did some of this last week when we did some of the linear stuff. So it says find the slope and the y-intercept of each line, and then let's go ahead and graph it. So remember what we're doing here. We're coming back to y equals mx plus b, right? And if you remember, m is our slope, which we called the rise over the run. And in this case, our m is the number 3, so I'm going to think about it as 3/1. And then the value for b, remember this here is always going to be my starting point. So in this case, we're going to have 0, and it's always 0, and then whatever b is, 0 and -1. Okay, so the first thing I'm going to do is I'm going to say, okay, where's the point 0, -1? From the middle, we stay here, and then we go down 1. So 0, -1 is right there. And then since my slope is 3 over 1, I'm going 1, 2, 3, and over 1. And there's our line, right? And if you notice, guys, our slope was positive. So our line goes up. Hello, hello. Come on in, come on in. You can see there's plenty of room. All right. So guys, let me go ahead and go to the next one here. Again, I'm going to do the same thing that we did the other day, right? So I'm going to come back to this problem here, y'all. And I'm going to say, look what remember what it is I'm trying to do. I want to get my equation in the form y equals mx plus b. This here is our slope, which is the rise over the run. And then this one right here is always in the point 0 and b. And this is what we call our starting point, right? And it's always going to start on that line right there. Okay. So the first thing I want to do here, I want to take this equation and I want to make it look like this one here. So if I have 4x minus y equals 7, then what I want to do is I want to get the letter y by itself. So I'm going to take this 4x right here, and I'm going to move it to the other side. So if I move that over, this piece is still going to stay here. So I'm still going to have a negative y. Now remember, when I'm crossing the equal sign, guys, the sign of my term is going to change. So it's a 4x right now. It's going to become a negative 4x. This 7 was already on that side, so that one doesn't change. It stays a positive 7. All right, and then, so now what I need to do is I need to get the y by itself, and I still have a negative in front of it. So, but I really want y'all to do, think about this as a -1. And since it's being multiplied, the opposite of multiplying is to divide. So I'm going to divide everything here by -1. A -4 divided by -1 is just a positive 4. But a positive 7 divided by a -1 is a -7, right? Okay. So now, if we do a little stare and compare, and we look at what we had here, and we look at what we have here, remember what we're going to do. We're going to say m, in this case, is 4. And I always want to think of my slope, y'all, as a fraction. So whether it's a whole number or not, I'm always going to think about it as a fraction. I'll just write it like this, 4 over 1. And this way, now I have a fraction, okay? Remember, the top number is the rise, and the bottom number is the run. And then our y-intercept is going to be, in this case, 0 and a -7, because it's the last number, okay? So now that we have that, this point 0 and -7, remember, that's always going to be my starting point. And remember, since it's the y-intercept, it's always going to start off on this line. So 0, -7 would be a little further down. That's -5. That's got to be -6. So -7 would be somewhere right about here. Okay. I'm obviously having to do this. I'm doing this because I didn't have enough lines, but that's okay. And then our slope is 4 over 1. So what am I going to do here? I'm going to rise up 4 spaces. So I'm going to go 1, 2, 3, 4, and then go over 1. And if you want to do it again, you can. 1, 2, 3, 4, and go over 1. And there's 1. Right? And remember, since my slope was a positive 4, my line is going up, right? What do y'all think? Are we doing okay so far? We're good? Okay, just checking with you guys. If something doesn't make sense, y'all don't be shy. Speak up. Well, it's just us. Okay. So looks like we got another one here. So let me scroll down to this one. And all I'm doing here, y'all, I'm playing the same game. Remember what it is I'm trying to do. I'm going to try to take my equation and I'm going to try to put it in this format right here. Okay. So again, this thing here is being solved for y. So if I'm going to solve for y, what I'm going to do is I'm going to divide both sides by 4. And we end up with y equals a negative 3 over 4 with an x. So remember, we want to find a couple of things here. We want to find our slope. The slope is the number that's in front of the x. So in this case, my slope is negative 3/4. The other thing we want to find the value of b, our y-intercept, right? So remember, the first number is always 0, and then the second number is whatever b is. And if I look over here, I don't see anything. Since there's nothing there, that number is also 0, right? If there's no number there, we understand that that number is going to be 0 because we could always write it as plus 0 or something like that, right? Okay, so remember, guys, the y-intercept here is always going to be my starting point. Okay. So 0, 0 is right here in the middle. Okay. And then if we look at our slope, it's negative 3/4. Remember, the top number is the rise, and the bottom number is the run. Since the top number in this case happens to be a negative 3, we're going to go down 3. So we're going to go down 1, 2, 3. And then we're going to move over to the right, 1, 2, 3, 4. And here's my line. All right. What else do we got here? Whoa. So that looks like that is all of 2.5. Okay, so guys, that took me about 17 minutes to do, right? Because we started around about 6 o'clock. Let me check. I want to check one thing. See if anybody, Laura doesn't seem like she's got any questions. Oh, wait, did I see something in here? Laura's good. Okay, I saw your thumbs up now. Laura, just double checking with you. All right, so I told you what we'll do, guys. 2.6 is like a super short section, and I think in your homework you only have like 3 problems, something like that. So what I want to do, let me go ahead and go through 2.6, and then what we'll do is we'll take the rest of the time to answer any questions, okay? So let's take a look here. 2.6 is graphs of basic functions, okay? And really what 2.6 you guys have, and I'm actually gonna pull something up here, and Lada, I'll share that with you in a second, Lada, because I know you're watching at home. Let me go like this, and let's see. Go this way. 2.6. Yeah, y'all only got about 3 questions. So let's take a look-see here. What does the first one look like? So we're going to do something real quick here. Copy this and here. All right. So what I'm going to do here, y'all, is I'm going to do some of the problems directly from the homework from 2.6. You only got 3, and this way there's no like, how do I do this? How do I do that? But I want you to look at my problem right here. And all I did here, guys, is I just copied and pasted this from my lab. But I want you to know this problem is almost the same, right? It's the same type of problem, okay? So anywho, let's go ahead and go through this problem here. It says for the piecewise linear function, find f of negative 4, f of negative 2, f of 0, f of 3, f of 5. Okay, so what piecewise functions are is exactly what they sound like. They have pieces. So the function f of x is going to be equal to 3x anytime the number x's that I'm picking are smaller than or equal to negative 2. But if the number x that I pick happens to be a number bigger than negative 2, then this is the piece that I'm going to use, okay? So when I do the first part right here, and it says, let's find f of negative 4. The first thing we're going to do, remember, these here are the numbers that we are using for x, okay? So the first thing I want to ask you guys, negative 4, would you say negative 4 is smaller than negative 2 or bigger than negative 2? What do you think? Smaller, right? Okay, so it's going to fall in the first part. So what we're going to do, since we're going to use the first part, we're going to say, well, what's 3 times what number are we using? Negative 4. That number happens to be negative 12, okay? And then we're going to keep doing this. We got to do it 5 times because there's 5 parts, but that's basically what it is we're going to do. So look, now we're going to do the next one, f of negative 2, okay? So I'm going to look at this number here, and it says we should use the top part again if we're picking numbers smaller than or equal to negative 2. Well, hey, that's equal to negative 2, right? So because this piece right here, that little arrow means smaller than or equal to, right? And guys, if you ever get confused and you're like, how do I know if it's smaller or bigger? Do this. Draw yourself a number line, put your negative infinity here, your infinity here, put 0, and just start doing this. Look, 1, 2, 3, 4, 5. And then this one looks the same way. Negative 5, negative 4, negative 3, negative 2, negative 1. As you keep going here, that's smaller. And if you go this way, that's bigger. So any number that's to the left of another number is always going to be smaller. Okay? So think about it this way. Negative 5 and negative 2. Which number is smaller? Negative 5 is smaller because it's further to the left, right? If we finished early tonight, I said, hey, let's go get a laksa, right? Because it's so hot. And you look at me like I'm going to pay, and I look at you like you're going to pay. And I go to the ATM, and I try to take money out. It doesn't let me, and it says my balance is negative 5. And you say, no te mortifiques, sir, I'm going to get it. And you go to the ATM, and you can't get any money, and it says your balance is negative 2. Well, neither of us have any money, but I actually have less money because I owe the bank $5 just to be okay with them. Well, you only have to pay them 2. Okay? All right. So now let's take a look here. We're going to use the top part of that function again. So we're going to say 3 times negative 2, negative 6. Okay? So we did part B. Now let's do part C, which is f of 0. Okay. So now we got to ask ourselves, is 0 smaller than negative 2 or bigger than negative 2? It's bigger, right? Just take a look. Here's 0, and there's negative 2, right? 0 is further to the right, so 0 is going to be bigger. Okay? So that means I'm going to use the bottom part. So I'm going to put 0 minus 4, which is negative 4. And then we're going to do the same thing for this one here, f of 3. So we know that 3 is bigger than negative 2. So again, we're going to use the bottom part. So 3 minus 4 is a minus 1. If I have $3, but I owe you 4, I still owe you $1. And then for the last part, f of 5, we're going to do the same thing. We're going to use the bottom part. 5 minus 4 is 1. Okay. So look at the answers we came up with. Negative 12, negative 6, negative 4, negative 1, positive 1. I'm going to stop sharing this real quick, Lada, so I can show you what I'm going to share with you. And Matthew, it's quick again. Excellent job. So let me do this so you guys can see. Okay. So I want to say for the first answer, we came up with negative 12. We're going to check it. For the second answer, we came up with negative 6. We're going to check it again. For the third answer, we came up with a -4. Let's check that again. For this one, we came up with a -1. Check that one. And the last one we came up with was a +1. And there we go, right? So we got it. Okay. All right, so let's take a look at the next problem, and it's the same sort of idea, guys. And I'll do one more. I'll do this one here, and then we'll stop here with this part. All right, so let me go ahead and copy that. And popping up like this. And this down. Stop sharing that. Let's try this again one more time. I can see this now. So it's like this. Okay. So same kind of thing here. Use the piecewise defined function to find the following values for f of x. So just like we did earlier, we're going to find f of 0. So my question here, which piece do we use? If the number we're plugging in is smaller than 4, we got to use the top part. Well, 0 is smaller than 4, so I'm going to put 3 minus 4 times 0, which is 3 minus 0. That should just be 3. And come back here, let's plug in the 3. Let's check it, good. Okay, now they're asking me to do f of 2. So I'll share the screen with those of you at home in a little bit too. F of 2, okay. I'm still going to use the top part because my number is still smaller than 4. So 3 minus 4 times 2. And 4 times 2 is 8. And that should give me a -5. And so right here, I'm going to go -5. The next one is asking me to do f of 5. Let me leave this up here so you can see it. Okay, now it's asking me to find f of 5. So notice, 5 is not smaller than 4, so I'm not going to use this piece. But 5 is a number between 4 and 8, so I'm going to go ahead and use that one, because this number happens to fall between 5 and 8. So what's 3 times 5? 15, right? Boom. So we're going to come back over here one more time. And we're going to plug and chug. And say, hey, that's 15. And now we got an f of 7. Let's go ahead and do f of 7. And again, 7 is still between 4 and 8. So I'm still going to use this piece right here. And we know that 3 times 7 is 21. Right here, we'll just go 21. And we got an f of 8. Now we're going to do an f of 8. Okay, so now we know we're not using the top part, so I'm going to go ahead and scratch this out. Now, this one says it needs to be between 4 and 8, but it's not actually including 8 because it doesn't have the little line. It says if my number x is 8 or more, then I'm going to use that bottom piece because if x is bigger than or equal to, right? That's why it has that little line underneath. That means equal to. So bigger than, arrow points to the right. And if it has a little line, or equal to, and in this case, 8 is equal to 8. So we're going to use that bottom piece. So we're going to go 5 times 8 plus 4. So 5 times 8 is 40. And 40 plus 4 is just a 44. Check. And we got it. And so let me stop sharing this so I can share the other screen with those of you who are at home. And let's see. And this is really what I wanted you to see. So as we were going through them, guys, I was just plugging in the answers in because it was going to give me each of these values as we kept going, right? But again, that's really all a piecewise function does. It just tells you, can you plug it in? And whatever number you plug in, these pieces here are going to tell you which part should you use based on the number that you're plugging in. Does that make sense? Yeah. All right. So let me stop sharing this. And let me come back to my notes. And so guys, we did 2.5 and 2.6, right? So the question I want to ask you is, do you guys have any questions about anything so far from, say, chapter 2? So, yeah, like 2.1 through 2.6, because those assignments, guys, are due by Thursday night, right? And then, so guys, this coming week right now, once you finish up if you haven't finished up 2.5 through, or 2.1 through 2.6, you definitely want to finish that up by Thursday night. And then next Tuesday, we're just going to we're going to go over two sections. We're going to go over 2.7 and 2.8. So I want to answer questions out of 2.7 and 2.8 that night. I'll probably answer a couple of questions then. I'll probably do like 2.7 or 2.8. I don't know. I'll do at least one of them next week. And then I want to say that let's see, when I pull up our weekly activities folder, for week 5 and 6, here we go. So guys, we got a test coming up, right? And that test is going to start 2 weeks from tonight. So it'll be open on the 5th, which is 2 weeks from tonight, and it's going to run until Sunday the 10th. There is a 4-hour limit on the test. So what does that mean? Well, once you start it, you got 4 hours to do it. So if you start it and you say you started Tuesday night, say, I'll come back and do a little bit Saturday, it won't work that way. You got to have a window to get it done, okay? I put a 4-hour time limit, guys. It's not that it's going to take you 4 hours, but I put 4 hours there so that you don't worry about time. Okay? Just make sure that you have, like, carve out some time in your day. Don't say, well, it's 5 o'clock and I got to go do this at 6:30. Now you're giving yourself an hour and a half. You know what I mean? Don't do something like that. Make sure you do have time. Let's see. So, guys, just to give you a heads up, and let me share this with those of you who are at home. You can see this too. Oh, here we go. So this is in the week 6 folder that I shared with y'all. Open it up this morning. Let's see. Okay, so guys, let's see. There's going to be a review. The review has 49 questions. Okay, it is for a grade. It's just a homework grade. But then in class on Tuesday the 5th, which is 2 weeks from the night, I want to make sure that all we do that night is just answer questions. What do you guys want to know about the review? Okay, and then what y'all will do, guys, is then the test has 20 questions, and look what it says here. They come directly from the review. So those 20 questions on your test, I pulled them from those 49, right? I pulled them directly from those 49. Is it going to be the exact same question? It might. The numbers might change, but the problem is going to be the same type of question. You know what I mean? So guys, there's not going to be any surprises. There wouldn't be like a question that's just like, wow, we never did this. No, we did, and everything came directly out of the review, okay? That's why I say, guys, if you can do the problems on the review, then you should be fine for the test. And for the same problems, you can use your notes, you can use any calculator that calculator app we use. And then I did upload a formula sheet for you guys as well. So if you want to have a formula sheet, there is a formula sheet right here. Quadratic formula, storage property, stuff for the absolute value, the distance formula, the midpoint formula, the circle stuff. And then we're going to do some of this next week. This kind of stuff comes into play a little bit next week. But I do have the slope business, and we'll talk about this next week as well. So the parts that are kind of new will be this here and the compositional function. But all that stuff right there, guys, will be, there's your formula sheet. You know what I mean? Yeah, you can use a calculator, and you can use that calculator app too. So if you don't have like an actual calculator, guys, and I was showing you guys you can get that calculator app, Graphing Calc. I just found this out last week on Wednesday, and I want to see you guys Tuesday. Does anybody here not have the calculator, like not have an actual calculator using the app? Anybody? Or y'all have actual calculators? Do you have a calculator using that app? Okay, do you have iPhone or Android? Okay, so guys, that calculator app, let me see if I can do this real quick. Oh, man. And I'm sorry, those of you at home, I can't share this because I'm doing it here in class. But, let me see. go like this. Let me see if I can do this business. But doesn't appear to be. Let's just see. Let's see if this works now. Let's see. Okay. And okay. So, like I said, guys, if you're watching at home, I can't share this but I'm just kind of pulling up that Graphing Calc 83 app. So here it is on my iPad. Now it's spelled Graph, Graph. If you have Androids, it's free. If you have an iPad or an iPhone, now they're charging. But all you got to do is go to the App Store and type in something like graphing calculator, like graphing calculator TI-84, stuff like that. Okay, so this one right here, this Calculate 84, that one is free, and it works pretty much the same exact way. Okay, so you don't have to worry about paying it. But if you did want it, I'm just saying, if you did want to buy it, this one right here, I think it's like $5.99 or something like that. You can also go check out a calculator, guys, from the library, and you can get one from there too if you want to. And if you notice the way it's written here, its graph is actually spelled the right way. But on mine, I guess when I downloaded it, it was like a year ago, and they spelled it GRAF. But But anywho, so what I really wanted to mention is just that you can use that, and it works just like a regular calculator, like a regular graphing calculator. Okay? And when I send out videos like how you do this problem, how you do that problem, if I have used a calculator, that's what I'm using because I'm doing it on my iPad. So you can get it again on your phone. If you want to check out an actual calculator, you can. If you have an iPhone, get that Calculate 84. It works exactly the same way. Okay, it's not a big deal. But like I said, guys, the test is going to be there's going to be a 4-hour time limit. So if you start it, you just got to make sure you do it within 4 hours. Okay? And it will shut off at. I'll put the time here, but it will shut off at Sunday at midnight. So if you want to make sure if you decide to hit it Sunday, don't hit it at 11:30 at night because now you'll be out. So I was telling that to my stats class because they're taking a test too, and same kind of thing, applies, and theirs is due by tonight. So anyway, I just wanted to kind of go over that stuff there. But since I have you guys here, do y'all have any questions you want to ask me about anything from the homework? 2.1, 2.6, 2.4, 2.2, anything? And those of you who are at home, if y'all got any questions on homework, let's see. Okay, you got the calculator app loaded. Good, excellent. I'm glad you did. And those of you who are at home, if y'all got questions, let me know too, and I'm more than happy to answer them. So Lada or Matthew, if y'all got a question, go ahead and type it in the chat box, and I will answer it. Those of you who are here, if you got any questions, let me know. Like these here? Yeah. Okay, yeah, let's definitely. I'll tell you what, let's do this. Let's do the third one. Okay, so I'm going to go like this. Okay, so this is the third problem out of 2.6. And it says, find the requested value, so f of negative 2 for f of x, and it's going to be one of these two. We're going to end up using one of these two things, right? Okay, so the first question here should be negative 2. Is negative 2 smaller than or equal to negative 1 or bigger than negative 1? Smaller, right? Draw your number line if it helps, right? Here's 0, here's 1, here's 2, here's 3. Here's minus 1, here's minus 2, here's minus 3. Negative 2 is to the left of negative 1, so this means it is smaller, right? So that means we're going to use the top part. So we're going to say f of negative 2 is equal to 8 times negative 2, negative 16. So that would be my answer. Does that make sense? Okay, now let me ask you a question. Did this make sense? That's what, really what you're going to want to do, draw a number line, right? And whatever numbers they give you here, make sure that you mark those. And then anything to the left is smaller, and anything to the right is going to be bigger. So think about it this way: less than points to the left, right? So if you look at the arrow right here, less than goes to the left, right? And then greater than points to the right. And less than just means smaller, and greater than just means bigger, right? And then you'll just use the one that's gonna apply for, yeah, for the particular problem that we have. Does that make sense? Yeah. And so don't let that confuse you, right? Because it's exactly right. So look, if I come back here, so we said the answer was negative 16. We can check it. All right, we got it. But look, if I come back over here and I say, look, let me do this problem again. So it's a similar question, and I'm going to do this right here. I'm going to copy that, minimize this. Okay. And we'll go like this. Okay. So again, the first thing I'm going to do here is I'm going to draw a number line. 0, 1, 2, 3, minus 1, minus 2, minus 3. Okay. So look at the number we're looking at. Negative 2, right? So here's my number negative 2. Anything this way is smaller. And I'll even do it like this. And then anything this way will be bigger, right? So when I do the first part here, f of negative 3, is negative 3 smaller or bigger than negative 2? Smaller, right? So we're going to use the top part. So 3 times negative 3, that's negative 9, right? And then we're going to do it again, f of negative 2. Now, see how it has the equal to part? That's why I filled the circle in right here. So it's really smaller than or actually equal to. So if it's smaller or equal to, I'll still use the first part. So 3 times negative 2, negative 6. Because as long as if it has that equal to part, I'm going to use that number as well, right? So now look, when we do f of 0, look at 0. 0 is what? Bigger. So then we're going to use the bottom part. Does that make sense now? That's right. Better? There you got it, right? And then look, we'll do the same thing here. F of 2, 2, still bigger, so we'll still use the bottom piece here. So we'll say 2 minus 4 minus 2, and then 5, so the S still bigger, and 5 minus 4, positive 1, right? And then we got it. So yeah, if it helps, just draw that little number line on your paper, and then you know exactly which part you're going to use. Do I use the top part, the bottom part, or like the second problem we did, it actually had 3 parts, right? So you'll put, like, if I was going to do, say let me do this one again. Let me just do this real quick. Let me scooch over once, and let's go similar question, and let me copy this one here. And copy it, and we'll do this right here. Okay, so I'm going to draw, first thing I'm going to do, I'm going to draw my number line. Okay. And I'm going to put 0, 1, 2, 3, 4, 5. I'm going to make this a little bit bigger than the others, 6, 7, 8. And I'll even make it a little bit more. I'll even go up to 9. Okay. So I'm going to be using numbers 2 and this way for the first part. Now, I'm going to use the second part if my numbers are between 2 and 7. And then when my numbers are 7 or more, I'm going to use the bottom part. Right? So when I do the first part here, f of 0, 0 is over here. So that tells me, hey, let's use the first part, right? So we're going to go 4 minus 5 times 0. 4 minus 0 is just 4, right? And let me keep doing this so that we can keep getting our answers. So we said the answer here was 4. Check it. Good. F of 2 is the next part. So now we're going to say, okay, what is f of 2? Because that circle is filled in, I'm still using the first part. So I'm going to go 4 minus 5 times 2. So this is 4 minus 5 times 2 is 10. And if I have $4, but I owe you 10, I owe you 6, so minus 6, right? And we come back here, and we'll go right here, and we'll say that's a minus 6. We check, boom. And then f of 4. Okay, so now f of 4, look where we are. We're in the middle piece, so we're going to use that one. So f of 4 is going to be 3 times 4. Well, we know that's 12. So I'm going to come back over here. I'm going to put a 12 right there. Okay. And then f of 6 is the next one. 6, I'm still using that middle piece. So 3 times 6, that's going to give me 18. And so we'll go right here, and we'll put 18. All right, and then we got f of 7. Okay, so now if you look at 7, now I'm starting to use the last part because the 7 is being included on the last part. So we're going to say, let's do this. Let's go like that. So f of 7 is going to be 4 times 7 plus 5. That's 28 plus 5. That should give me a 33. And we were done, right? That was a lot better. So yeah, I think drawing the little number line is going to make it a lot easier to do, right? And then you can get it. Good, good, good. Any questions? Anybody else have any questions about anything? 2.2? Let's do it. Okay, so let's go like this. Let's come back here. Okay, and we'll come here. 2.2. Which one are you looking at from 2.2? Number 13? Okay, so guys, I'm going to copy this and I'm going to put it up on the screen. Yes, this is a good problem. So let's do this here. Okay. And we'll go like this. And this. Okay, so this is from 2.2, y'all. This is number 13. Okay, so it says give the center and the radius of the circle represented by the equation, and we have our equation right here. Okay, so the only thing I'm going to do here, y'all, is I'm just going to rewrite this problem. I'm going to rewrite it so I put the x's together, and I'm going to rewrite it so I put the y's together, but I'm going to leave that negative 44 over there on the other side. So I'm going to put x squared here, and then I'm going to put a minus 12x because that's the piece that we got. And then I'm going to put a y squared and a plus 6y because that's the piece that we got. And then over here, we already had a negative 44. Okay. So what we do with these problems here, y'all, we're doing something that we call completing the square. Okay. And completing the square, it's kind of a long process. But once I do the first one, we're going to do it twice. Once I do the first one, hopefully you guys can help me figure out how we're going to do the second one. Okay. The rules are going to be the same. We're going to take the number in front of the x. Okay. And so guys, I'm taking the number with the sign. So the one thing you want to be careful of is if it's negative, don't forget the negative part. Okay. So we're going to take that number negative 12. The first thing we're going to do, we're going to divide it always by 2 every single time. Guys, this process is going to be the same no matter what numbers we have, okay? So my first question to you, what's negative 12 divided by 2? Negative 6. Okay. Then we're going to take that number, negative 6, and we're going to square it. Remember what that means? That means we're going to take negative 6 times another negative 6. What do we get? Positive 36. Okay. I'm going to put a 36 here, and I'm going to put a plus 36 here. Okay. Now, the next thing we're going to do, y'all, we're going to factor this piece. Now, there's going to be a way it's going to work out every single time. This thing here is going to end up being a perfect square. So it's going to be the same thing squared. Okay. Think about it this way. What times what's going to give me x squared? X. That's going to be always going to be the first number. Now, the way you're going to figure out what am I going to put over here, you're always going to take this number or this number here. It's going to be the same number. Whatever number you got when you divided it by 2 is always going to be the number that's going to go right there. Okay? We have done what we needed to do for the part with the x. Now, I want to see if you guys can help me do the same thing, but now we're going to do this to the y. So remember what we did? We took the number in front of the x, so now we're going to take the number in front of the what? In front of the y. What's the number in front of the y? It's a 6. What's the first thing we're going to do with that number? Divide it by 2. And the number we get is 3. What was the second thing we did? We put that number in a box, and we did what with it? Squared it. Okay, so let me fix that 3 because that's a pretty rough-looking 3. Okay, what's 3 squared? Okay, good. So guys, remember what we did with that number? We added it over here, and we're going to add it over there. Okay. So now what we're going to do is we're going to factor this piece. And it's just, and there's a plus right here in the middle. I should put a plus right here. So I'm going to put a plus right here. And it's going to look exactly the same way. There's going to be a y here. There's going to be a square here. And I got to figure out what am I going to put there. So just like we did before, we said we're going to take this number. Once we divide it by 2, that was the number we put here. What number should we put over here? What kind of 3 is it? It's a positive 3, right? So we're going to put a plus 3. Okay. Now, will somebody do me a favor? Anybody who has a calculator, can you tell me what is minus 44 plus 36 plus 9? Minus 44 plus 36 plus 9 is? Anybody know? Negative 44 plus 36 plus 9? 1. Okay. All right. Now, we're almost done. If you remember the other day when we talked about the circles, we said that our circles always look like this. Okay? But the center of the circle is just the point H and K, and the last number is always the radius. So if you remember what we said before, do you remember what we said? If you look at the sign here and you look at the sign here, but then look at these, we said we have to change those signs, right? So if I was going to do that here, what would you say the center of this circle is? Now what are we going to do? We got to change our signs. Positive 6 and a negative 3, right? We're going to change the signs that are there. And then the radius is going to be whatever number you have to square to get 1. So what times what gives me 1? 1 itself, right? So right here, I would say the center of the circle is 6, negative 3. And the radius of the circle, we would say is 1, right? And we're going to pull up our screen right here so we can double check it. And we said the center of the circle was 6, negative 3. And the radius happened to be 1. And we're going to chickadee check. There we go. Yes, ma'am. Okay, so remember the last number here? This number here is the radius once it's been squared, right? So really what I'm doing, I'm taking the square root of 1, right? I would ask myself, what times what gives me 1? Well, it would be 1 itself, right? But I'm going to make this up. If my last number was 25, then the radius would be 5, right? If my last number was 49, then my radius would be 7, right? What am I doing? I'm taking the square root, right? What times what gives me 25, right? Or what times what gives me 59? It's got to be the same number, right? Same number when multiplied by itself. So I'm really taking the square root of that last number. Now, guys, the one thing I want to emphasize, remember what the first thing we did was we took the number in front of the x, and we took the number in front of the y, and we divided them by 2. It's always going to be by 2. And then what are you going to do? You're going to square that number, and you're going to add it over here, and you're going to add it over there, right? Don't worry about what you're going to get over here. We'll do that part at the end. And then when you're going to write it as a perfect square, it's always going to be x with this number and y with that number. Don't forget the sign. So if it's positive 3, that's where we put the plus right there. Right? And then when we're going to do the center, we say, let's take these signs and let's change it. It's always going to be the reverse. And then you got it. And it'll work like that every single time. Right? Good, good, good. Any other questions, anybody? I'm sorry? Yeah, let's do another one like that. So let me come back here, and let's go similar question. Okay, let me copy and paste this one here too. Boom. 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 So let's do another one like that just to make sure that we got it done. Okay. All right, so remember the first thing we're going to do, we're going to rewrite it so that the pieces go with each other. X squared minus 10x, leave a little space. Y squared plus 2y, leave a little space. Negative 10. Okay. All right. Anybody remember the first step? Take the number in front of the x, which is good. Divided by 2. What do we get? Negative 5. And then what do we do with that number negative 5? We square it. What's negative 5 times another negative 5? Positive 25. Okay, good. So look, right here, we're going to put a plus 25, and we're going to do the same thing over there. Okay. Now, before we go to the y's, let's fix this piece. Let's rewrite this as a perfect square. So give me a hint. That's going to be a square. That's going to be an x. Do you know what we're going to put on the inside? What are we going to put next to that x? Negative 5. Good. Like that. Always a number when you divide it after you divide it by 2. Good. Okay. Now, we're going to play the same game we did before, but now we're going to take the number in front of e, which is positive 2, and we're going to divide it by, we're going to get 1. Then we're going to take that number 1, and we're going to square it, and we're going to end up with 1 again. Voila. So then right here, we're going to put a plus 1 and a plus 1. Okay. And then we're going to see we can fix this part right here. So I'm going to put a plus right here. Now give me a hint. This is going to be a y. This is going to be a squared. What am I going to put right there? Positive 1. You got it. Okay. Now, if you got a calculator, anybody know what negative 10 plus 25 plus 1 is? $16. Very good. Okay. All right. So now, let's take a look. What is the center of our circle? Anybody know? Positive 5 and? Very good. What about the radius? There you go. You got it. Remember, it's always the center. You're always going to change the signs that you got. If you got a negative 5, it's a positive 5. You got a positive 1, it's a negative 1. And then why is the radius 4? Because what's the square root of 16? 4. You know? And so now I'm going to come back over here, and I'm going to say, let's do a little plug and chug. So we got a 5 comma negative 1. And the radius we said was 4. And we go chickadee check. And you got it. Take it away. Good, good, good. Any other questions anybody might have? Sorry guys, I'm not sharing the right screen. Those of you who are at home. Oops. Sorry about that. I just realized that right now. I'm back. Sorry about that, y'all. Okay, there we go. We're sharing the wrong part. Okay. Number 7, in what section? 2.5? So let's do this. Let's go back here. Let's close it up. Do that part. Okay. And let me come back here. 2.5. I said number 7. Okay. So let me see if I can do it this way.
Okay. All right, let me make sure that those of you who are at home can see this now. I think you all can. Yeah, you can. Okay. Sorry about that, guys. That was my bad. I thought I had it on the right part, but I didn't. Okay. All right, so it says the graph of a linear function is shown. Identify the slope, the y-intercept, the x-intercept, and then write an equation that defines f. Okay, so the first thing we're going to do here, we want to find the slope. So guys, I want you to think about this line. Look at the direction of the line. Is that line going up or down? It's going down, right? So that tells me my slope's going to be negative. Okay. So what I'm going to do is I'm going to see if I can find some points on this line. So I'm going to zoom in real close so I can see this. Okay. And so like right here, I see there's a point right there, and I see there's a point right here. Okay. So when I'm going to do my slope, right? Think about if I want to get, say, from this green point to that green point, how many spaces do I have to move down? 1, 2, 3, 4, 5, 6, 7, 8. So -8 on top. How many spaces do I have to move to my right? 1, 2. Okay. So -8 divided by 2 is the same thing as a -4, right? So what I'm going to do here is I'm going to say the answer here is -4, and I'm just going to plug that in here. So we can say, let's make sure that that's working. -4. Get that. We're doing great. Okay. The second part says, now let's find the y-intercept. And look what it says, guys. It says type an ordered pair. So we're going to write the coordinates of a point. Now remember what the y-intercept is. The y-intercept is where it hits the y-axis, right? So look, if I zoom back in right here, does anybody know what would be the coordinates of that point? If I was going to write it as a point using x's and y's, what would the x coordinate be and what would the y coordinate be? 0 and 8, right? So 0 and 8. Why? Because we're not moving anywhere on the x-axis. We're just going straight up to 8, right? So remember, the first number is always the x. Second number is always the y. So if I'm not moving to the right and I'm not moving to the left, then my x is going to be 0. And then we just go up to whatever number we have, right? So in this case, it's 8. So what I'm going to do here is I'm going to put, for the y-intercept, it's the point 0 and 8. And I'm just going to plug that into my answer here. Open ordered pair, chickadee check. We got it. We're going to do the same thing for the x-intercept. Okay, so now let's see if we can find the x-intercept. Okay, so I'm going to scroll back over here so I can zoom in so I can see it. Just like we did before, now I want to know what are the coordinates of this point down here. 2 and 0, right? Because we just moved to the right 2 spaces. We didn't go up or down after that, so it's 2, and then the y value, since we're not going up, going down, 2, 0, right? So I'm going to come back over here, and I'm going to say my x-intercept is 2, 0. Okay. Right here, 2, 0. Okay, chickadee check. All right. Now, look at the last part. It says, write an equation that defines x. Okay, so let's do that. Remember how we were writing these equations? Since these here were all lines, weren't we doing this? Y equals mx plus b, right? That was the form we were using. We did this last Tuesday night. So remember, we just found our m. Our m was a -4. Then there's an x that goes right next to it. All I'm doing is filling in this value. And then the b is the y value of my y-intercept. In this case, the y value happens to be the number 8. So I'm going to go plus 8. Okay. So here's my equation. Y equals -4x plus 8. Now, guys, because we are using function notation, f of x and y mean the same thing. So I'm just going to write it like this. F of x equals negative 4x plus 8. And so when I come over here to my answer, I'm going to write f of x equals negative 4x plus 8, put a capital X. And we got it. What y'all think? Did it make sense how we were able to do it? You doing okay? Y'all sure? Okay, just checking with you guys. Any other questions anybody might have? Anything? Don't be shy. Lana, Matthew, do y'all have any questions y'all want to ask me since you're there at home? Which one? Of course, 2.5, number 2. 2.5, this is that. 2.5, number 2, let's do it to it. Okay, so let's take a look here. Let's go like this. Okay. And we'll copy this, bring this down, and back over here. Okay. All right, so it says write an equation of the line passing through the point negative 4, 7, having a slope of negative 4. And then notice what it says, give the answer in slope-intercept form. Okay, so remember, the first thing I'm going to do, I'm going to write out this form. Y equals mx plus b, right? Okay. Does anybody remember, what does the m stand for? It stands for the slope, right? Okay, so what that's telling me is that my m is the number negative 4. Okay. Now, guys, remember, when we have points, every point has two coordinates. It has an x coordinate and it has a y coordinate, right? So what this is telling me is that x is the same thing as negative 4 and y is the same thing as 7. So right here where the y used to be, I'm going to put a 7. Where the m used to be, I'm going to put a negative 4. Where the x used to be, I'm going to put a negative 4 also. And then the one letter that I still don't know right now is b. So let's see if we can find it. So look, I'm going to go like this. 7 equals negative 4 times negative 4 is a positive 16 plus b. And if I want to get b by itself, I got to subtract 16 on both sides. Okay. And so I'm just going to use my calculator real quick. Let me turn it on. I'm going to say, what's 7 minus 16? Negative 9? Okay. So this is a negative 9 is equal to b. Okay. So now that we have that, what we're going to do is we're going to say, look, we're going to come back to this equation, and we're going to write it out like this. Y equals m. M was negative 4 with an x, and then plus b. B in this case ended up being the number minus 9. And so there's my answer, right? And what I'm going to do now is I'll just come back to this right here, and we're going to write y equals negative 4x minus 9. We'll go chickadee check. We got it, right? So the one thing I really want to mention is that this part right here is super helpful in doing a lot of these problems, right? But guys, one thing I want to mention real quick, and I'm not going to pull this up for those of you at home, guys, because I don't want to miss it again. But if I pull up my formula sheet, it should be here somewhere. Boom. Right there in the middle, y equals mx plus b, right? And again, you'll be able to use your notes and that kind of stuff, but formula sheet's going to be super, super helpful in how to doing some of these problems here coming in. Yeah, without a doubt. Whatever you have, yeah. Now, the one thing I want to mention is, remember, you got 4 hours, right? So what I don't want you to do is like, okay, let me do the question number one, and then you're looking for everything, right? The idea should be that if you have to do that for every problem, there's 20 questions. You may not finish it for 4 hours, right? So you want to have, like, you should reference your notes, but if you have to look on every single problem for your notes, I would say spend some more time doing the review. Do some of those problems over, but just like the way we said, can you do that one again? So we did another again. If you need to do that a couple of times so that you're not having to look through everything every single time that you're like if you see a problem like this, you're like, okay, I remember it. Or if you see a problem like the one you asked me about with the circle, right? And then we did another one, the circle. Okay, take the number in front of the x, divide it by 2, square it. Whatever number I get, put it over here, put it over there. And then remember how we're going to write it with a square? It's always x with that number once we divided it by 2, right? Same thing with the number in front of the y, right? Take it, divide it by 2, square it, add it to both sides. Y with whatever number we got after we divided by 2, put all in parentheses, square it. And then remember when I'm going to do the center of my circle, what do I do with the signs? We change them, right? And then to find the radius, always the square root of the last number. What times what gives me that last number, right? So yes, you can use all your notes, but what you don't want to be doing is having to go through everything every single time, because then it will take you the full 4 hours to do. You know what I mean? So that's always the drawback of when people say, oh, I can use my notes, but then you're like, oh, I don't really need to study because I can look through everything, but it takes you longer to look through it. You know what I mean? So that's the part I just want you guys to be careful. Any other questions y'all guys want to ask? You still got about half an hour. I just want to make sure that. I'm sorry. Well, that's what I want to wait for that until Tuesday, because I want to make sure that we have, like, so like Tuesday I'll go over. Yeah, yeah. So yeah, you all have time. Like the 2.7 and 2.8, I just opened that up today, right? So next Tuesday we'll make sure that we go over some of that stuff, and then the Tuesday after that is when we'll say, okay, let's review for the test. You know what I mean? I'm sorry. Say it again. On the 5th. Yeah. Right. So the 28th is a week from today. So that day we'll go over 2.7 and 2.8, because I just opened that stuff up today. You know what I mean? I just opened it up today, so I want you guys to get a chance to go over some of that stuff, and then Tuesday, and I'm going to pull this up real quick here to see what we still have left. 2.7. 2.7. I'll tell you what, guys. This is what I would do if I was you guys. 2.7 can be a little tricky, but 2.8 is less tricky. So I'll tell you what, between now and Tuesday, on your own, try to see if you can do 2.8. You should be able to, you don't have to do 2.7, you don't have to know 2.7 to do 2.8, okay? So try to do as much of 2.8 as you can, right? Watch the video, whatever you got to do. And then on Tuesday, when we come back, I'll go over 2.7, because 2.7 can be a little bit tricky, okay? So I'll I'll go over this section with us in class, right? And I'll answer some questions you guys might have at a 2.8, but I'll go over 2.7 in class. And then remember, the following Tuesdays, all we'll do that night is just review for test one, right? So you'll say, so next Tuesday, once we go over 2.7, then your responsibility between that day and the following Tuesday is start working on the review. So that day that you show up, you can say, sir, how do I do number 7, number 15, number this one, number that one out of the review? Does that make sense? Yeah, so let me pull this up one more time. So let's see, where is it? Right here. So we'll see each other on the 5th, and what I'll do is that night, from right before we meet, I'll say, look, I'm going to open up the test in case anybody wants to do it later tonight. And it'll run until Sunday the 10th, right? You'll have 5 days to do it, but there's a 4-hour time limit, right? So whatever day you're going to do it, that's the day you're going to sit down. And you don't necessarily need all 4 hours, but you'll have 4 hours to say that. That's what I'm saying. Make sure that whenever you start it, your time is going to be uninterrupted, right? You don't want to start it and then, well, I have to go to work in 30 minutes because now you got 30 minutes to get it done. You know. Any other questions about anything, y'all? You good? If y'all don't have any questions, you are free to go. Those of you who do have questions, hang out. You know, but if you don't, you're free to go. All right, you're welcome. Take care. So yeah, like I said, 2.8 guys is it looks more complicated than what it is, and I'll since those of you are still here, I'll show you. I'm going to just show you the first problem, just so you can kind of see the idea. Because again, I don't want you to get like too frustrated, like, oh my God, what does this mean? What does this mean? So let's do this real quick. Okay. So let me just do. I'll just do this first problem here out of 2.8, and then we'll call it a night. This one right here. So if you look up here, we have something that we call the sum function. Sum just means we're adding, like sum, difference, product, quotient. We're either adding, subtracting, multiplying, or dividing. So when it says, how do we do f plus g of 1? We're going to do it like this. We're going to say, what's f of 1? And what's g of 1? And then when we get those answers, let's add them together. Well, we already know how to find those because here's our f of x and here's my g of x, right? So if I said, what's f of 1? I would say, I'm going to come back here. I'm going to put 1 squared plus 1. Well, 1 squared is 1 times 1, which is still 1. And 1 plus 1 is 2. So this is going to be 2. G of 1 says, let me come back to this part right here. And G of 1 says, let's take 3 times 1 plus 5. And 3 times 1 is 3, and 3 plus 5 is 8. Okay? So now, f of 1 plus g of 1, what's 2 plus 8? Okay, you got it done. That's all you have to do. So think about it like this. Take a look at the next one here. The next one says, what is f minus g of negative 3? What am I doing here in the middle?
I'm subtracting, right? So that means I'm going to find f of negative 3. I'm going to find g of negative 3. And then I'm going to subtract. Right here? Right? It's already given me that value. You see what I mean? It's given me the value that it's telling me to use, right? So look, how do I find f of negative 3? Well, I just come back to this problem. And I say, look, if I want to find f of negative 3, I'm going to take negative 3 squared plus 1. Negative 3, when I square it, is 9. And 9 plus 1 is? So I'm going to put a 10 right here. And I'm going to do the same thing for g of negative 3. So I'm going to come back to this part right here. And I'm going to say that's 3 times negative 3 plus 5. So that's negative 9 plus 5. That is a negative 4. What do we say we're doing? We're subtracting. But remember, minus and minus makes it plus. So my answer here is 14. You see what I'm doing? No? I mean, are you okay how I came up with this part? Okay. So think about it this way. Whatever you have, whatever they're telling me to do in the middle is what I'm going to do. So like if I come back, right, let me erase this because it's not really necessary. But what do I have in the middle here? Add. So once I find those two answers, add them. What do we have in the middle here? Subtract. So once we find those two answers, subtract them, right? Look at this one. They're right next to each other. So they're right next to each other. What are they being done? Multiply, right? So look, I'm going to come back here. F of g of 5. Let me find f of 5. I'm going to come to this guy again. 5 squared plus 1. 25 plus 1 is 26. Okay. Then we're going to do the same thing for g of 5. So I'm going to come back to this guy right here, and I'm going to say, what's 3 times 5 plus 5? That's 15 plus 5. That is 20. So when this part says, what is f times g of 5? That's the same thing as saying f of 5 times g of 5. But we know what f of 5 is. That's 26. And we know what g of 5 is. That's 20. So I'm just going to take my calculator, and I'm going to say, what is 26 times 20? 520. Whatever the operation is in the middle, we are dividing. Good. And look what number we're going to plug in. We're going to plug in 0. Okay, so look, let me do this. I'm just going to clean this mess up because I don't need it for every single one. Okay, so now let's do this. F of 0. 0 squared plus 1 is 0 plus 1, which is g of 0. Okay. 3 times 0 plus 5. 0 plus 5, which is 5. And now we're going to go like this. F of 0 divided by g of 0. Well, f of 0 is 1, and g of 0 is 5. My answer is 1 over 5, right? You can do the same thing using a picture. Remember what this means. We're going to find f of 4. We're going to find g of 4. Once we do, what are we going to do with the two answers? We're going to do what? What do we have in the middle here? Add. Okay, f of 4 means do this. Here's x is 4. We want to find the y value here. What answer did we get? So here I'm going up to 4, and I'm going to go up until I hit the blue graph. What's the y value there? There you go. We're going to do the same thing for g of 4. We're going to come up here. We're going to hit this. We're going to go to the right. What number is that? There you go. What's 9 plus 2? There you go. Does that make sense? Okay. And then we'll keep doing the same thing each time, right? So look, we're going to do the next one here. We're going to find f of negative 2. We're going to find g of negative 2. What are we going to do with our answers in the middle? Subtract them. Okay, f of negative 2. Look, let me clean up this mess again. Right, and we'll go like this. F of negative 2. So here's negative 2. You go down. Oops. You go down. What value do we hit? There you go. Okay. I do the same thing we did before, negative 2. But I want to hit the g function. If I go up or down, do I ever hit that graph right there? Okay. What we say here, it's undefined. Why? Because when I go to negative 2, I'm never going to hit that little, when I go to negative 2 over here, I'm never going to hit that curve, right? Okay. If one of them is undefined at a particular value, then the whole thing is undefined. Undefined just means I can't do it, right? The number isn't there, right? Let me ask you a question. Could we do this at 1? Look at the next one, part C. Could we do this at the value for 1? So here's 1. If I go up, what number would that be for f of 1? There you go. Let's see if we can do it for g of 1. Boom, there we go. We hit it. What number do we have there? 1. Look what we're doing with them. They're right next to each other, so they're being multiplied. 3 times 1 is? There you go. Does that make sense? Okay, one last one, and then we'll call it a night. Oops. There you go. I'm going to go like this. F of 0, which means, right here, f of 0. I'm going to go up. What number did we hit? 1. Okay. G of 0. What number did we hit there? 0, right? Now remember, what are we doing with them? Okay, so f of 0 over g of 0 is 1 divided by 0. Guys, here, is undefined. We cannot divide by 0. 0 is the one number we can never, ever, ever divide by. Okay? Now, I did this with one of my other classes, a different class. I did this with them the other day. And I want to show you guys why is it undefined. Okay? So this is just a little idea on why it's undefined. What is 24 divided by 8? Does anybody know? 3. Okay? Now, if I asked you why, wouldn't you say 8 times 3 is going to give me what number? 8 times 3 would give me 24, right? Okay. So then if I said, what is, I don't know, let's keep it easy. What's 36 divided by 4? Anybody know what the answer would be? 9, right? And I've asked you the same question. If I said why, well, you would say, well, 4 times 9 is going to give me 36, right? Okay. Now, if I asked you, what is 0 divided by 7, we would say 0, right? Now I would say, why? Well, 7 times 0 is going to give me 0, right? Look what we had here. We had 1 divided by 0, right? So let's do 1 divided by 0. What's 1 divided by 0? We couldn't put 0. You know why? Because 0 times 0, is that going to give me 1? Okay. So we're just kidding. It's not 0. Maybe we thought it was 1. But is 0 times 1 going to give me 1? No. We're just kidding again. Do you see that no matter what number I put, right? I'm sorry. Do you see that no matter what number I put right here, when I multiply it by 0, it's never going to give me one answer. It'll never give me one, right? So that's why we say we can't divide by 0. Okay? So anyway, 2.8 is easier to do than 2.7, okay? I would encourage you, watch the video. If you got to watch it more than once, watch it more than once. Try to do the homework. I would also recommend, if you can, you don't have to take any notes, just watch the video for 2.7. But next Tuesday night, I'll cover 2.7 in class, and we'll go through those problems. That's going to take a little bit longer to do because 2.7, I'm not going to lie, it's a little bit tricky. So I'm going to go through 2.7, okay? But I'm going to take our time with it. We're going to go real slow to make sure that we're all on the same page. The Tuesday after that, all we're going to do that night is review. So really what the goal should be is from here until next Tuesday. So I'll put it this way. Between today and Thursday, make sure you finished up to 2.5 because that's what's due by Thursday night, right? From here until next Tuesday, make sure that you've done 2.8. Try to do as much of that homework as you can. Whatever problems you can, we can take some time to answer them at the end after I finish lecturing on 2.7. And then next Tuesday night, what I'll do is I'll lecture on 2.7, and then between that Tuesday and the next Tuesday, the two things you'll want to do is, number one, make sure I finish the homework for 2.7, and number two, make sure I start working on that review so that when we see each other the following Tuesday, all that night you do is, sir, how do I do this one from the review? How do I do that one from the review? How do I do this one? And we can make sure that we can get as many questions answered as we can. Yes, ma'am. The review should be there already. Yeah. The review is there. So let me pull this up again real quick. Yeah, you can start working on it. Yeah, I would, and what I would tell you to do, that's actually a good idea. I would tell you, yeah, so if you take a look here, the review is already here, right? The review got open today, and it's due on the 7th, right? It's due on the 7th. So, like if you pull up the review, right, and you go to question number 1, what's question number 1? Okay, solved by the zero factor property. This is when we did the factoring stuff, right? But some of the questions you'll already know how to do because this is some of the stuff in chapter 1, right? So whenever you have time, try to do just a couple, right? And you can skip around, right? So like, look, if I was sitting where you're sitting, this is what I would, yeah. If I were you guys, they changed the format of this thing. There used to be a little thing where I could click down and I could go to other problems right away. But what I would probably do if I were you guys is, okay, didn't we do a problem like this the other night? Okay, I would do that one. The mid segment. Okay, look, center on the radius of the circle. Hey, we did some of that stuff too. Look, isn't this a problem that we did tonight? Boom, I would knock this one out. Why? Because you already know how to do it, right? And it's fresh in our minds. I would do something like that. I would do something like, let me come back over here. We know how to find f of those numbers. I would try to do all the ones that you, like the ones that you know that you don't have to put in a lot of work, like I can do this one. Do those, right? And so that would tell you like, hey, you know what, remember these problems are all coming from the, oh, what is it? Okay, we come back here. Okay, there it is. Look, hey, we've done stuff like this before too, but, and I'm trying to find the slope of the line, graph the line. These are problems that we've already done. All the, like this one, we did one like this exactly tonight too. All the ones that you know that you can do without having to like put too much into it, I would do those. And then what we were talking about in terms of can I use my notes? Yeah, anything. So that you know that when you're taking the test, some of those problems you know you're going to need to know. The ones that you know you're going to need to know, make a little mark. Like on the review, I know I need my notes for number 1 or number 11 or whatever. And the reason, make sure somebody have these ones that you're going to know. Go back. So like suppose you were doing question number 1. I'm just going to make this up. I mean, log out of here real quick. Suppose you know you needed your notes for number 1. Once you did number 1, once you've answered that question, and I'm gonna enter my answers in real quick. Here we go. Let me see what they're going to be.
6, comma 9. I'm gonna go like that, check my answer. Okay. What I would do, if I knew this was one that I needed my notes for, I would go similar question. And I would do those more than once. So you could say, okay, you know what? Now I know I'm a little bit better with these. You know what I mean? And this way, when you go take the test, the ones that you already know how to do, that you don't need a lot of effort, you know, you're going to breeze through those. And then the ones that you know you need a little bit more time, you'll have that time. Does that sound like a plan? Awesome, awesome, awesome. Okie dokie. So let me stop sharing this, and let's see. Let me see. Loud, are you still? Yeah, Loud and Matthew are still there. So I hope you guys could hear what we were saying. Um, but anyway, if y'all got questions, y'all let me know. I'm gonna go ahead and stop recording our session.